70-740 Lesson 3, Configuring Disks and Volumes. So in this lesson, we're going to be looking at how we go about configuring disks and volumes. We'll be creating virtual hard disks, not only using Hyper-V, but illustrating how to do it from your Windows operating system. You can create a virtual hard disk in Windows. So we're going to also be looking at how we use disk management to configure our disks, to initialize them, to partition them, all the different ways that we use disk management. And we can use PowerShell to do those same functions. Well, and as I previously mentioned, we'll take a look at how we create a virtual hard disk in Windows and mount it within our Windows operating system. We'll be taking a look at file sharing, how we can use shared folders with basic and advanced sharing, and configuring SMB using our server manager. We can also do this through PowerShell. And then finally, we'll be taking a look at file and folder permissions and understanding NTFS permissions and viewing permissions, and then combining NTFS and share permissions. So let's go ahead and let's get into it. And like every one of our other lessons, at the start of the lesson, you can see a number of the key terms that will be covered in that lesson. And these are all terms that will be explained as we go through the lesson. For example, we can see right here we have Small Computer System Interface, SCSI. We learned about this in A+. Let's get a little bit deeper dive into it. So understand that years ago, storage used to be very expensive. The capacity of our storage devices has drastically increased over the years, and the price of that storage has drastically decreased. The other constant in that is your users are always going to find a way to need more storage. Nobody wants to delete emails. Nobody wants to get rid of anything. You never know when you might need it again to reference that email that you received from a business partner years ago. So typical user data might include multiple versions of their documents, copies of other users' documents, high-def videos that they downloaded, or perhaps were shared for training purposes or any other purpose, or just about any other thing that a user simply doesn't want to delete. They're not ready to delete it. I can tell you from experience, email, I would examine someone's inbox, and their inbox was clean. It was perfect. There was only relevant information in that inbox. And then you'd look in their recycle bin or their deleted items folder, and there would be hundreds and hundreds of emails. And you'd say, well, why haven't you emptied your recycle bin? Why haven't you emptied your deleted items? Oh, I don't know whether I want to get access to them later on. There might be something there that I need. And my thought was, well, then why would you throw it in the garbage? Why would you throw it in our home? If we throw something in the garbage, we don't throw it in there with the intention of later on digging through the garbage and taking it back out. Educate your users the same way. If they're going to delete something, they need to keep their maintenance up to date and also delete those deleted items. Okay, went off on a little bit of a tangent there, but that's okay. Knowledge is power, right? Okay, let's move on. So nowadays, it's very common to see drives with 1 terabyte, 2, 4, 8, 16 terabytes. Drives have gotten huge. So how do we access those drives? Well, there's a number of different types of interfaces that we might have. Very common with our servers today is SCSI, the SCSI, Small Computer System Interface. And understand that it's a set of standards designed to connect and transfer information between high-speed devices and a motherboard. The devices are connected in a chain. Each device in that chain gets an ID, and there's got to be a terminator on that last device. In other words, something to indicate that there's nothing else beyond it. Now, that used to be very common. Nowadays, SATA has pretty much replaced SCSI on most modern computers. And SATA is Serial Advanced Technology Attachment. That's what SATA means. And it's a serial interface that transfers our data in bursts instead of in parallel. When SATA was first released, we had SATA 1.0, which transferred at best 1.5 gigabits per second. And then that moved to SATA 2.0, which doubled the transfer rate, and SATA 3.0, which again doubled the transfer rate. So while the SATA numbers, the version numbers have incremented by one, just remember that each version of SATA and each newer version of SATA doubled that speed. And that is theoretical throughput. It'd be rare for you to actually see that 6 gigabits per second on SATA 3.0. Understand, though, that they have a maximum throughput of 150 megabits per second, 300 megabits per second, and 600 megabits per second, respectively. We can also have eSATA, external SATA, and this allows us to connect those SATA devices externally. And then, of course, we also have USB, Universal Serial Bus. And theoretically, we could connect up to 127 peripherals, that is USB devices, to a single USB port. Where we get the power, can we transfer enough power through that single USB to power all those 127 devices? No, that's not going to happen. We would probably daisy chain it with a number of USB hubs that have their own power supply. Remember that from your previous learning, USB 2.0 had a maximum transfer rate of 480 megabits per second, and 3.0, which came out now, 12 years ago, it had a theoretical maximum transfer speed of 5 gigabits per second. These are theoretical. These will never be seen in actual practice. When it comes to our actual drives, there are two different partition styles we can use, and two different types of disks, two primary types of disks, that is. From the partition style, we can have the MBR master boot record or the GPT GUID partition table. And those primary types of disks are basic and dynamic. And we'll get into what each one of those are in a little bit more detail right now. So when we install a physical hard drive, and when we first access that, it's a basic disk. It can only contain simple volumes. A dynamic disk, that's where we can create our RAID, spans, striped, and mirrored volumes. Understand that traditionally basic disks use partitions and logical drives. A partition is a defined storage space on a hard drive. And remember, to be usable, that hard disk needs to have at least one partition. A volume is a partition that's been formatted to have a file system on it. The master boot record MBR partition, it's been around for quite a while. And all Windows operating systems support MBR partitions. Now, remember that MBRs have their limits. At most, you can have 4 basic partitions, and each partition is limited to a maximum of 2 terabytes in size. You can have 4 primary partitions, or up to 3 primary partitions with one extended, and that can be further divided into logical partitions. So also remember that an MBR is a single point of failure. If it gets corrupted or damaged, the computer's probably not going to start. Now, the GUID partition table GPT style, it allows for more partitions and larger sizes. As you can see in your learning here, that you can have up to 128 primary partitions on a disk that's initialized as GPT. And each one of those partitions can be as large as 9.4 zettabytes That's really big. Understand that 1 zettabyte, that's equal to 1 billion terabytes. They use a 512 byte sector. And then also remember that the maximum raw GPT partition size is 18 exabytes. You can't use GPT partition styles on removable disks. Remember that. GPT's been around since Windows Server 2008 and newer, and that corresponded with Windows Vista. Remember, as a side note, that each version of Windows Server corresponds with its own operating system for the desktop. When Windows Server 2008 came out, it corresponded to Windows Vista. When Windows Server 2008 R2 was released, that corresponded to Windows 7. Windows Server 2012 corresponded to Windows 8, and 2012 R2 was Windows 8.1. And then, of course, Windows Server 2016 corresponded to Windows 10. Now, you can typically convert a basic disk to a dynamic disk, and you're not going to lose any data. But you know what? You better back it up just to be sure. If you have some software or hardware that doesn't work with dynamic disks, you might need to convert that dynamic disk back to basic. When you first initialize a disk, this is when we're going to specify whether we're going to use MBR or GPT. Now, you can convert an MBR partition to GPT, and you simply right-click the disk and you choose Convert to GPT. However, be aware, if the Convert to GPT disk option is grayed out, you're going to need to back up all your data, delete all the partitions, and then convert it from MBR to GPT. What do we use those dynamic disks for? Well, we talked about that. We can use that to create RAID volumes. We could just do a simple volume, but the main reason is for us to do redundancy, for performance, for a mixture of both. A spanned volume spans your data across multiple disks, and you can do that with up to 32 disks. A mirrored volume's RAID 1. You've got 2 disks, and each disk is a copy of itself. So that gives you single drive failure, the ability to stay online if you have a single drive failure. A striped volume, this stores data across 2 or more physical drives. The data on a striped volume is written evenly to each of the physical disks in the volume. You can't mirror or span a striped volume. Striping is often referred to as RAID 0. If you're going to write 2 chunks of data, one chunk gets written to the first disk, another chunk gets written to the next disk, and to the next disk, and to the next, and then back to the next, and to the next. So all the data is stored across all the disks. Remember, in a RAID 0, if one drive fails, the entire volume fails. All data is lost. We can manage these disks and volumes and file systems from disk management using Windows PowerShell or the command line disk part command. So let's take a little bit of a look on how we do that. So when would we want to format using NTFS or REFS? This is probably a new term for you, REFS. That's Resilient File System. Well, what is a file system? Well, this is the structure that your computer uses to name, store, and organize files and folders on a hard disk or partition. It's basically a map of the clusters, which you remember is the logical storage, those basic units of logical storage on a hard disk. When you install a hard disk in a computer, before we can use it, we have to format it with a file system. Now, by far and away, the primary file system choice for today's Windows computers is NTFS. Now, also is FAT and FAT32. FAT and FAT32 have been around for a long, long time, but they're really not used much at all anymore. About the only time you'll see FAT32 is maybe on a USB, and there's no really reason any to use that anymore either. Understand that a FAT32 partition, it's limited to a maximum size of 32 gigabytes, and the largest file that you can store in a FAT32 volume is 4 gigabytes. So if you have, let's say, a 16 gigabyte USB and it's formatted to FAT32, and you go, wow, I really like the way that this Windows image is, and I want to use that to format my computer. So I want a copy of that Windows image. Say, for example, uh, you are going to work with a system that's not connected to a network, and you want to build virtual machines. So you download a copy of Windows Server 2016 Eval, the evaluation version. Well, let's take a quick look at what the size of a typical Windows uh, 2016 server is. And if I can bring that up here, I'm going to bring that over. Okay. Okay, so here we can see some ISOs that I've downloaded. And now, for example, here we are. Windows Server 2016 Data Center. The ISO is almost 6 gigabytes in size. Well, if you look here, if our FAT32 volume can only have a maximum file size of 4 gigabytes, will you be able to copy this ISO to that USB and then transport it to your environment where you don't have an access to the internet? Because that's the only way you're going to get files. If you're not connected to a network, if you're working in some type of isolated test environment, you need to be able to transfer those files somehow, and USB is probably the way you're going to do it. It won't work. You won't be able to use FAT32 to transport that file size. This is why you'll not use FAT32. Our file sizes have simply gotten too big. Our partition sizes have gotten too big. It's common nowadays for a USB to be 64 or larger in gigabyte size. So a FAT32 simply won't work. So remember that NTFS is the preferred file system on our Windows systems. Now, what was that REFS, Resilient File System? It's an enhanced NTFS file system, and it can support much larger volume sizes and files. It also offers greater resiliency, better data verification, error correction, and scalability. Now, you should only use REFS for very large volumes and file shares. You can't create a boot volume using REFS. So it's for storage. Now, remember NTFS, it only supports a file name up to 256 characters. In REFS, you could have a file name of 32,000 characters long. Why you would, I have no idea, but it's possible. REFS does use a subset of NTFS features, so it's backward compatible with NTFS, but it can only be accessed by Windows Server 2012 or higher, or Windows 8.1 or higher. Now, you have to have a fixed allocation unit size of 64 kilobytes, and it doesn't support the EFS encrypting file system. It's mainly for storage. For example, where I came from, the business that I used to be the systems and network administrator for, we had a server that was dedicated to do nothing but backups. And that backup server, that software, that special software that it ran, used volumes that were formatted with REFS. You'll typically use it for Hyper-V workloads. There's there's some advantages, there's some performance advantages with REFS in conjunction with VHD and VHDX files. Or you might use it if you're going to implement storage spaces direct. Or if you're going to archive data that you want to retain for a very long period of time. That resiliency that REFS brings in can benefit your archive data. So let's take a look at some of those comparisons. Remember that FAT, even older FAT file system, you could only get up to 2 gigabytes. FAT32 was still a maximum of 32 gigabytes. NTFS with 64-bit clusters could have a 256 terabyte maximum partition size. REFS, 1 yobi byte. That's big. And the partition size with exFAT is 128 pebibyte. That's pretty big. With that last one we just mentioned, the exFAT, that is the extended file allocation table. We use that for our flash drives, for those USBs. You don't have to use FAT32 for a USB for compatibility. Use exFAT. It supports those larger file sizes and larger partition sizes that breaks the limit so that you can transfer those ISOs. exFAT's also been adopted for SD cards by the SD Card Association. Now, we're not going to go into all this detail. Remember from your A+ sector sizes, it's the minimum storage unit. The allocation unit is also known as a cluster. It's the smallest amount of disk space that can be allocated to hold a file or a folder. When we use a single byte of an allocation unit, the entire allocation unit is allocated to the file that contains that byte of information. So if you specify allocation unit size, let's say of 64 kilobyte, that means every single cluster is going to be 64 kilobytes minimum size. Have you ever looked at the disk information for a computer and the size on disk is different than the actual size? Well, that's because of this. Let's say you create the size of your allocation unit when you're doing your formatting, and you specify 64 kilobytes. And you have many files that are much smaller than 64 kilobytes. 5 kilobytes, 10, 30, 25. Well, if you have 100 files that are only 32 kilobytes, they will consume on disk twice as much space because the minimum size for each one of those clusters is 64 kilobytes. That's how that works. Now, how do we manage disks? Well, one of the ways is using disk management. Let's take a look at that. Now, over here I've got that server setup disk that I created in lesson 2. So let's go ahead and get logged in on that. What I've done is I've created a couple virtual hard disks and attached them to this virtual machine. And you can do that too using Hyper-V. Simply in the virtual machine, go up to the top to the File option and go to Settings. And I could select the SCSI controller. And because it's running, there are some things you can't do, but you can add disks. And I could simply click Add. I could say New. I could say Next. I'm going to make it dynamically expanding. What is dynamically expanding? It starts out very tiny, and it increases as you store information and store data on that disk. So if we watch, it's going to be dynamically expanding, and I'm going to call this server setup disk 3 because I've already got 2 other ones. And actually I'm going to put a dash right there so I can see the difference. I'm going to go next, and you can see it's going to be a blank disk of 127 gigabytes. Is it going to take 127 gigabytes of my storage? No. Let's take a look. I'm going to click Next. We can see what it's going to make. I'm going to click Finish. And there's our new drive. I'm going to apply. And you saw it change from that bold blue, and it's now normal type. As you make changes, if you make changes to a virtual machine, it'll indicate where you've made changes by making the text bold blue. And until you hit apply, those changes aren't set. So I've now got 3 disks that I've attached. Let's take a look at that storage. Where's my Hyper-V storage? Right over here. Hyper-V, virtual hard disks. Let's scroll down. Server setup, disk 1. Look, it's 4 megabytes in size. I haven't done anything with these disks. We'll come back to this in just a minute. In fact, what I'm going to do is I'm going to move it over here so we'll still be able to see it as we're working. Over here on our virtual machine, I'm going to go ahead and hit OK. Our server's up, and we can right click on the start button and go straight to disk management. Disk management opens up. I'm going to just go to the top of the menu bar, left click and drag it up. That'll make it full height. And I'm going to move our divider bar up a little bit so we can see our 3 disks that I've created, and I'm using 32 gigabyte drives. The first thing we need to do is we need to bring them online. Before they're online, we can't access them. Once they're online, they still have not been initialized. So I'm going to right click and I'm going to say initialize disk. I'm going to initialize all 3. On second thought, I'm going to initialize 2 of those disks as GUID partition tables. The 3rd disk I'm going to initialize as MBR. If later on we decide we need to take advantage of the GUID partition table features, we can simply right click and convert to GPT. They're now ready for us to format for our use. We can right click, we could create a simple volume. In other words, we could allocate some or all of this to a formatted file system with a drive letter. We could create a spanned volume, striped volumes, mirrored volumes, a RAID 5. And each one of the indicators, just as you can see, this has like a dark blue, almost a bluish purple on the title bar for the disk. Each partition style has its own indicator as far as color, and we'll take a look at that here in just a few moments. But for example, let's say we want to create a mirror. You're going to create a drive mirror of 2 drives so that the data is equal across both. We can simply select disk 1 and disk 2, click Next. We can assign a drive letter, or we could mount it to a folder. We could say we want to mount it and make that available as if it's a specific folder. We could opt not to assign a drive letter or drive path at the time. We'll go ahead and we'll assign drive E. We'll click Next, and we're going to call it Mirror. We'll do a quick format, and we click Next and Finish. It's going to convert it from basic to dynamic, and the formatting should begin in just a moment. There we can see the different color bar? Mirrors have this color bar. Other types of file systems, partitions, have different colors. Let's take a look at that while that formatting is taking place. We can see our disk management that we're working in. We did the initializing. We showed the converting from basic to dynamic. We could have created a simple volume. We went past that though. We looked at converting from MBR to GPT. And here are those different stripe colors. A simple volume simply has that dark blue. A spanned volume would have purple stripes. A striped volume would have aquamarine stripes. The mirror has that burgundy red. And if it's RAID, it's going to be cyan stripe colors. So while that's continuing on, and it's probably not done yet, we're just going to take a quick look there. Nope, it's not done yet. Oh, no, I take that back. It is. There it is. There's our mirror drive letter E. What if we wanted to have a RAID 5 take advantage of a 3-disc? What does that do? Well, you still only have single disc failure capability with a RAID 5, but you have to have a minimum of 3 discs, and you get the advantage of having the total capacity minus the contents of 1 disk. So if I have 3 1 terabyte disks and I create a RAID 5 array, I will have a 2 terabyte capacity. If I have 4 1 terabyte drives and I create a RAID 5 array, it will be 4 disks minus the contents of 1 for a total of 3 terabytes. Let's take a look at that. First off, we need to delete the volume. We say yes, it's unallocated. We're going to go ahead and we're going to go rescan just to make sure it reads the information correctly. We'll right click again, we'll say new RAID volume. Remember, RAID 5 is only available in Windows Server, it's not available in Windows 10. And we'll select our other 2 disks. We have 3 disks selected. We select next, next, and I'm going to label it RAID 5 so it's easy to recognize what we did. And finish. Convert back to dynamic disk again. There's the conversion taking place. Now I'm only working with 32 gig size simply to have it happen a little bit faster. It's resynchronizing. The formatting should be taking place. This should be done in just a moment. While it is, let's go ahead and go back to our textbook and take a look at some of our other information. We can do all these functions from PowerShell. So we could, for example, get disk. Let's take a look at that on my system. We'll make that a little bit smaller. In fact, let me show you how to make that smaller. You go up to the very top left, you go to Properties, you go to Layout, and I'm going to take the window size from a height of, this is the buffer size, not the actual size, but I'm going to change this to, let's say, 120. Let's make it 150 and 30. Still pretty wide. Let's make it a little bit different size. So you're getting more than just a lesson. Let's make our font a little bit smaller. It's a little bit better to work with. We can simply run the get disk command. It inquires my system and returns back with exactly what the systems are, what the disks are that are available. We could say get partition. And there are the partitions that have been formatted. At the same time, we could do new partition, new volume, remove partition, set volume, and here are some of those settings spelled out. Initialize disk and the disk number. For example, initialize disk 1, partition style MBR. We could do new disk, new partition, disk number 1. Use maximum size, so it could automatically use the entire size and assign a specific drive letter to it. So everything we do in the wizard, we can do from the command line. How do we work with VHDs? Well, we can take and we can create a virtual disk in Windows. So for example, I'm on my physical system. And I'm simply going to right click and I'm going to go to disk management. This is on my physical computer. And I could say action, create VHD. And it says, well, where do you want to create it? I'm going to create it on my H drive, and I'm going to call it temp.vhdx. The VHDX is a better format. Use it. It's a newer format. VHD is older. I click save, and I'm going to change this from megabyte to gigabyte, and I'm going to say 32 gigabytes. We click OK. Oh, I'm sorry. We got to select VHD because we typed VHDX. We got to select VHDX because that's what we selected up here. We'll leave it dynamically expanding. We click OK. And we now have a virtual hard disk that we can initialize. We can create a volume. And there it is. And in our computer, it appears as a completely separate drive, even though it's part of our volume H. There it is. Let's go ahead and we're going to delete that partition. I'm going to take it offline, and I'm going to detach the VHD. What did that do to the size on disk? (167 megabytes). I'm going to go ahead and delete that. We don't need that anymore. Let's take a look back overall on our virtual machine. We're 41%, 42% formatted in creating a RAID 5 array. So we just looked at how do we create a virtual hard disk. We can do that through PowerShell as well. Now, file sharing. So for the most part, users never log into a server. Users log into their desktop computer and they access the resources of a server. We create file shares, shared folders. They access these. They might be automatically created and appear as a drive letter on their computer, even though they're hosted on a server somewhere. Through the years, we've had various versions of Server Message Block SMB, and this is also known as the CIFS Common Internet File System. And it's a client server file sharing protocol. Microsoft created it all the way back in 1984. Now, there's been a lot of enhancements to it over the year. It started out with SMB 1, SMB 2.1, 3.0, 3.02, and you can see those incremental changes over the years. And here's a synopsis of what those different versions have brought to the table. How do we create those basic shares? Let's go ahead and let's take a look over on our server setup. It's almost done formatting, but we don't have to wait for that. I'm going to open up File Explorer. Now it's going to be a little sluggish because it's doing that disk format. But we'll go to this PC and I'm going to open that up and we're going to create a new folder and we're going to call that data. We'll right click on that folder that we just created and go to properties. We can go to sharing and we could simply say share and say who we want to share it with. Most times, however, you're going to use the advanced sharing button. And we'll say share this folder, and we could share it as a different name now, if we so desired. We can select permissions. We can select who has what permissions. For example, we could say administrator, and administrator gets full control, but everyone else only gets read. Different permissions for different reasons. We can hit apply and OK. This is now shared on our network. If we close, and now what is the name of our server? Well, it's kind of an abstract name. There it is. This is the easy way to copy it. If I go back over to File Explorer and I do a whack whack server name, there's the shared folder. Obviously there's nothing in it right now. Sharing a file is just that easy. Basic share, your advanced sharing. So understand your basic share simply doesn't give you that fine control that we do through the advanced. In the advanced, we can share files, folders, a whole drive. We can choose those users or groups that we want to share the files or folders with and how we want them. We could limit the number of users who could access something at the same time. A lot more control under advanced sharing. And there's those steps that we just did. Now also in computer management, we can see what's being shared on our computer. So if we come back over to our server, let's see where our progression is with our RAID 5. It's almost done. And I'm going to come over to computer management. And we're going to allow that to open up. Well, I'm going to do it this way too. Could be just running a little slow. Okay, there we are. And I got 2 copies of it. Got a little impatient. Okay, so right here, shared folders. If we expand that caret, here we can see what shares are created, and right there's our data. As a side note, note the admin $, C $, and IPC $. These are automatically created administrative shares. The $sign on the end indicates that it's a hidden share. So for example, if we bring File Explorer back up and I do the // server name and hit enter, the only share I see is that data folder that's been shared. However, if I select this and I do another / and C and $, and press enter, I can see the contents of the hard drive on the system. So this is an administrative tool for you to be able to view the contents of the drive on a remote computer. Just the same way as you saw me type in the server name and the /C $, you could do this to any other system that you have the rights to manage. What if I were to type in admin? What does that take me to? It takes me to the Windows folder. This is the Windows folder on that system. We can see what sessions, who's connected. Well, because I opened it up as a session, that's why you see this. And what files are open? There's no files that are open right now. We can use Server Manager to create a new share. So if we go into Server Manager, on the left side we select File and Storage Services. We can then drill in. For example, we can click on Shares and Tasks New Share. So here's our servers, here's our volumes. We can see shares. There's no shares. We could do tasks. See, we have to add the roles and features to be able to use that file server role. It's not installed on this server yet. And those exact same things we can do through PowerShell. And here are all those commandlets. And here is some examples of how to do that from PowerShell. Now, how do we go about changing and configuring file and folder permissions? Well, we have share permissions. Share permissions are set for folders when we share them in work groups and domains, but they're only associated with a folder. Share permissions only apply when you're accessing the share via a UNC path. What are those share permissions? Well, there's read, change, and full control. Now, NTFS file permissions give you the ability to control who can access your files and folders, regardless of whether they're accessed from the network or whether they're accessed locally by logging onto the computer. And this is done from the Security tab. And here again, we would probably go to Advanced. Let's take a quick look at that. If we go back to our File Explorer, we select this PC, we go to the local drive, and I'm going to right click on the data folder and go to Security. So here we can select Advanced, and we can see what permissions who has. What about the share? What permissions are assigned for the share? We can add. We can enable auditing so that we can see what is accessed and what type of access. Was it successful? Was it failed? We can view effective access. If we had users configured on here, we could select a user and see what effective access they're allowed. Many different things that you can do through the Security tab. And here are some of those NTFS permissions that are allowable. Understand the difference between explicit permissions and inherited permissions. Explicit permissions are granted directly to a file or a folder. So, for example, us granting those permissions to that data folder. Inherited permissions, they are permissions that flow into child objects. So, for example, coming back over to here, data. If I go into data and I create a new folder called user data, and I right click and go to properties, and I go to security, I will see the same permissions inherited. And you can see here, this gives us the ability to disable inheritance and set our own permissions for this, or to replace all those permission entries with inherited permissions. So in other words, go back. Those are inherited permissions. So a subfolder, a child folder, gets the same permissions as its parent. What are the differences in those inherited permissions? We can see that here. Make sure you understand the difference between inherited permissions and explicit permissions overwrite. Understand that those explicit permissions will overwrite inherited permissions. Okay? Moving on. We can calculate effective permissions. We can understand that deny always takes precedence over allow. So if you configure two security groups, and we'll get into groups later on, but groups allow you to easily manage resources by making your users members of a group rather than having to add all the users to the thing that you want to share. So for example, this folder here, we could create a security group called user data access, and they would be the ones who would be have the permissions to this folder. As new users are created, they could be automatically given access to that security group, and you will have many security groups. By getting access to the security group, they're automatically given the permissions for the folder. Makes it easier to access. However, if you create two security groups and one of them is denied access to that folder and the other one is allowed access to that folder, and a user is a member of both groups, they will be denied access to that folder. Denied takes precedence. Okay, moving on. We can view those effective permissions. We took a brief look at that. Make sure you read through this. We can combine NTFS and share permissions and be able to look at that. Okay? Make sure you also understand NFS. That's Network File Systems. Network File System is a protocol that we can install, and it's used with Unix and Linux file server clients as well as VMware. So in other words, if you need to support any Linux, Unix, or VMware clients, you need to install the NFS protocol. It was originally developed back in the 1980s. So what you would do is you would install the server for NFS role service, and in this way then you can make those other clients be able to have access to your resources. Understand the steps required to do that. I'm not going to go into that in detail. We've already talked about a lot. Make sure you read through it. So we talked about that there's two different types of partition styles, both MBR and GPT, and there's two different primary types of dist, basic and dynamic. Using the basic, we can simply create a volume. Using the dynamic, we can create as well a simple volume, but we can also create spanned, striped, and mirrored volumes. Remember that while it's not available in Windows 10, in Windows Server we can create RAID 5 arrays. We talked about the different types of file systems, working with virtual disks, the fact that users don't log on to servers. Users access shares from a server. How read and read-write actions are configured, how those share permissions are set, how we need to plan your NTFS and share permissions. You're going to hear me say this many, many times. Plan, plan, plan. Plan it before you ever try to implement it. Take your time, do your research, do your planning, implement it once. It's better to write and rewrite a plan 15 times than to try to implement and then have to blow it all up and start from scratch again. Do your planning. We discussed how when users connect to a share over the network, both the share and NTFS permissions are combined, and the most restrictive of those is applied. And then finally, we briefly discussed NFS, but be sure that you understand how it can be implemented. Thank you for reviewing 70-740 Lesson 3.